Good morning, Algebra 3 class. I hope that this finds you well and that you've had a nice break and that you are ready to go and ready to keep on working on this trig. We're about to finish up the trig. Actually, this will be the end of our trig study, and we'll be testing by the end of the week on Thursday and Friday. That test will be pretty much like the quiz was that you had right before break. But we do need to finish up. We have looked at graphs of sine and cosine and tangent and cotangent. So now we need to take a look at secant and cosecant functions. So when we think about that, though, really secant and cosecant are really just reciprocals of the sine and the cosine. So when we begin to think about our cosecant, okay, our cosecant, if you remember, is a reciprocal of the sine. So we really need to consider what the sine graph looks like first, and we're going to use that as a guide. And we're thinking about the cosecant graph. First, you need to sketch it that are really not part of the graph. But we need to remember what our sine graph looks like. Okay, right here is shown two periods of a sine curve. Just to remind you from before the break what the sine curve looks like. Okay, so remember our sine starts at 0, goes up to 1, back down to 0, and one complete period is 0 to 2 pi. Now, I would highly suggest that if you've forgotten anything, that you go back and you rewatch the material on how to graph a sine and a cosine graph. Okay, because this is going to be huge for today, because both of our graphs we're going to look at today start with either a sine or a cosine. If we're looking at a cosecant graph, we need to think about what the sine graph looks like first. And this is going to help us give structure to our cosecant graph. Okay, now we said that it's reciprocal. Okay, so our y values are the values for our cosecant. Okay, so if we're looking at the reciprocal of 0, throw 0 into the denominator, that can't be. So our first thing that we need to notice is that we're going to get some asymptotes. And the asymptotes are going to show up anywhere the sine graph was 0, because the reciprocal of 0 over anything gives you undefined. So what you do is you throw in the asymptotes. Okay? Because of that whole idea of the reciprocal of the sine. Okay? So we've sketched first y equals sine of x. Then we need to think about, well, what else do we know? Okay, the other thing that we know is that this is a 1 value and this is a negative 1 value. If you take 1 over 1 and flip it over, because that's a reciprocal, the reciprocal of 1 is just 1. So this point is in common for both the sine and the cosecant graph. This value is in common because the reciprocal of negative 1 is just negative 1. The reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. So we have these points are our first point that we can actually graph. We can graph the asymptotes are just guiding lines, though. We can graph these individual points, and then we need to think about, well, what about the rest of the reciprocal? Okay, so for example, if I had a half, which the value would be right here, if I do the reciprocal of that, that would be 2. So that would be up here. If I had a quarter, which would be about here, half of reciprocal of a quarter is 4, so that would be up here. So you get this idea of when you do the reciprocals, here's a half, reciprocal would be a 2. What happens is as the fractions get closer and closer to 0, the reciprocals go further and further and further up towards infinity. So what you have is they're not parabolas that go in here, but you have a parabola-like U shape that goes up here for cosecant, but then it also happens this way because those negative reciprocals end up going down infinitely. So what our graph ends up looking like is we have our anchor points, which are the tops and the bottoms of our sine function, up towards infinity along the asymptotes. So what I would be looking for in a cosecant graph, I would be looking for your key points that you had on your sine graph would end up in the asymptote here and here. And I would be looking at direction going off into infinity. This is a discontinuous graph because we have to pick up our pencil to draw just for your reference so we can put things in context that I had told you about in the other ones. So we have our cosecant graph is based off of the sine graph, the reciprocals of each other as we discussed before. So what you should be is anticipating that our secant, since it's the reciprocal of the function, would be sine function. What a basic function looks like. Okay, here is what we had talked about as being our basic cosine function. I have it dashed because I'm only using it as a guideline to help draw the secant function. Okay, so once again, it works the same way. The asymptotes are on the x-intercepts. So the asymptotes here are at pi over 2, 3 pi over 2, 5 pi over 2. A complete period goes from 0 to 2 pi. This shows 2 periods. But this is not the secant graph, it's the skeleton, the thing that we base it off of. So we've got asymptotes that get thrown in. There's our asymptotes. So far I don't have a single point graphed for the secant. But once again, the reciprocal of 1 is 1. The reciprocal of -1 is -1. The reciprocal of 1 is 1. So we have these, okay, the tops and the bottoms of the cosine graph gives us some key points. And just like what we did before, it extends up towards and down towards infinity this way. Up towards infinity for the tops, and then down towards infinity like this. So the parts in red here are the graph of the secant function. I will be looking for your asymptotes to be in the correct places. I will be looking for these key points to be in their correct places. And I will be looking for the infinite parts to be heading in the right direction and approaching. All right, so we have here, once again, our basic cosecant graph is the red parts here, and our basic secant graph are here, and then they get shifted up, down, left, right, could be stretched, could be compressed. Both of them have a period of 2 pi. So far in our graphing, we have 4 functions that have a base period of 2 pi. We have 2 pi for a sine, 2 pi for a cosine. We have 2 pi for a cosecant, and we have 2 pi for a secant for being a 1 period cycle. Okay? The ones that do not have those numbers would be tangent and cotangent. Remember, tangent goes from negative pi over 2 to pi over 2. And cotangent goes from 0 to pi for their one complete cycle because they're very different. But sine, once again, sine is related to cosecant, and cosine is related to secant. All right, so let's start looking at some of these shifts. Okay, the first thing, really what you're going to do is you're going to graph the companion function, for lack of a better word. You'll graph that one first, use that as a skeleton, and then sketch in your cosecant or your secant. So remember, cosecant is based on sine, so we're thinking about, okay, what would I do to graph a sine function, and going from there. And we can look at this number. This number, once again, is going to designate our amplitude. And then this number is going to help us figure out the beginning and the end part of our period. Okay, so our amplitude comes from 2. That means it's going to be going up 2 and down 2 from our middle line. And then this part tells us that you have your standard period going from 0 to 2 pi. But this is the thing that goes from 0 to 2 pi. And when we solve for x, it's going to give us our actual 1 period gap. Multiply all 3 places by 3. So this one goes from 0 to 6 pi. Directly in the center is 3 pi. But then if we add and divide by 2 like we had been doing, 0 plus 3 divided by 2 gives you 3/2. 3 plus 6, 9 times a half is 9 pi over 2. So we have our 5 main places that I will be looking for your graph. So in order to start it so you get your right form, easiest thing to do is to sketch out your sine graph. Okay, we have here's our anchor points, 0 and 3 pi and 6 pi. 3 pi over 2 directly in between, and 9 pi over 2 in between that. These other little lines here is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, so that you don't lose context for any of this. But here are our 5 main places. Here is our skeleton that is not actually part of the graph. Your asymptotes. Remember, your asymptotes go in all of the 0 places, so I can throw in my asymptotes. There's one. There's one. Okay, there's my asymptotes. Okay. So we've got our asymptotes happening. Now, remember, you're just going to hit the top point, you're going to hit the bottom point, and then you're going to make your curves up towards the asymptotes. There's an asymptote hiding through here. You can't really see that very well, but here's that one. Starts here, goes up. Here's this one. Starts there, goes down. So these ghost lines are not really part of the graph at all. It's just this piece right here and this piece right here that are the graph of the cosecant function. I will be looking for your asymptotes to be clearly presented. I will be looking for the curves to be approaching those asymptotes, and I'll be looking for where it goes. Okay, please make your life easy. You've all got line graph paper. I've seen that. So count them off as being 1 and 2. Try not to put like little lines in between or do like random gaps. I think that you guys are pretty good with that, but now let's just make it nice and neat. Graph paper, of course, is the best, but if you don't have graph paper, actually notebook paper might be a little bit easier for you, because you're making an x-axis, you're making a y-axis, and then just using the lines to figure out how far away from the place where it cycles around is. Okay, so once again, cosecant is based off of do a sine graph and then throw in your points and your curves. Okay, secant, remember, is based off of a cosine graph. Let's remember, this one means it's going to shift to the right, actually. if you're thinking about it that way. But once again, this is going to have to go between 0 and 2 pi for one standard period. This one means something else. Let's think for a minute what this means. Okay, this 1/2 means it's going to be half as tall. It's cutting the amplitude in half. And this negative means that instead of going up to down like a normal cosine function, it's going to go down to up and be upside down. Okay, so there's what this means. The negative means upside down. The 1/2 means the amplitude is a half rather than going all the way up. And this is going to give us our shift. From 0 to 2 pi is our standard period. But this pi over 2 means that it moves over by, we're going to add pi over 2 to all three spots. Then find the middle. Pi over 2 plus 5 pi over 2 is 6 pi over 2. A half of 6 pi over 2 is 6 pi over 4, which reduces to 3 halves. 1 pi over 2 plus 3 pi over 2 is 4 pi over 2, which is 2 pi divided by 2 gives you pi. And then similarly, just like we did for the other, I don't have all that shown because you can look back and do those calculations for finding your 5 main point, just like you did for cosine. So what we do, we set it up. Pi over 2, pi, 3 pi over 2, 2 pi over 2. What you'll know by halves, half pi's. In a normal cosine, it would start up, go middle, go down, middle, up. It's upside down, so instead of starting up and going down, it's starting down and going up. But remember, it's only a half amplitude, which means that instead of going all the way to the 1, it's going halfway there. So half pi, middle, up, middle, down. This is our upside down cosine. All right, then drop in your asymptotes. Asymptotes only happen at the x-intercepts. So you would drop in your asymptote here and an asymptote here. There they are. Drop in your asymptotes, put dots on your key points, make it approach the asymptotes. If you were to go for another period, there'd be another asymptote here and this would curve back down around. Make sure you don't go past this point, okay? Some people lost a little point here or there because they sent the graph, even though you, within the period that you were focusing on, the things were done right, you then made it so that you showed that if it went beyond, it would go this way. Make sure that you end it right where your period that you're focusing on ends. But if you put an extra piece on, I have to go with that and say, oh, well, they thought it would go this way, but it doesn't. It actually goes back down this way. So if you choose to do more than one period, the part that you go beyond on, even if it's just a little bit, has to be correct. So make sure that you head these things in the correct direction. All right, now, here's the thing. This might take a while to wrap your head around. You do have to review. You do have to make sure that you're doing everything the way that it has to be. So tomorrow is going to be a work day on assignment 63. So tomorrow you'll be spending your 45-minute class period working on and getting assignment 63 ready to turn in and doing an excellent job at it. You'll be asking questions on that and making sure that you understand, or even putting questions on this so that you are sure to understand. On Wednesday, we're going to have a work day and test prep day, so you need to make sure that you are you're prepared for Wednesday to be test prep, and you'll be doing something that will count on assignment 64. Be sure to read the directions on the website for that. And then on Thursday and Friday, you're going to be having your Chapter 17 test, which will be, it's going to be the 6 different graphs. It will look very, very much like the quiz that you took on the first 4 types of graphs, but it's going to add secant and cosecant to that. So just basically, can you graph these different types of functions? Then when you move on to do pre-calc later on, you will be focusing on taking that into different directions so that you can build on this basic foundation that I've given you as far as the trig goes. All right, and that would be it for this lesson. Have a really fantastic, blessed day. Make sure that you are prepared to just keep moving forward and keep doing a really good job, and hopefully just keep praying that we get to see each other before the end of the school year. That would be fantastic. All right, God bless you. Have a great day.